instrument landing system, right? And this is one of the most widely used instrument approach system. Its whole point is to get you down to the runway really accurately. So speaking about an ILS, there are three main categories, or actually equipment, and three parts to an ILS. It's a system, right? So there's parts: guidance, range, and visual. So we'll start off with the guidance first. Guidance includes the localizer and glide slope. So if we go to the IFH or the AIM, so in this AIM, if you go all the way down to the bottom, you'll see the same picture in black and white. But if you want the colored version, just go to the IFH page 9-36. We'll dissect this one a little bit. So looking at the localizer is going to be at the departure end of the runway. So if we're coming in on this runway, here's the arrival and here's the departure end. It's going to be at the very end of it, departure end. This localizer right here is going to shoot out two signals, 150 and 90 hertz. All localizers are going to do this. All your plane's going to do is going to listen for 150 hertz and 90 hertz. If it receives more on the blue side, you're on the right side. More on the orange side, you're on the left side. Another visual representation, right? You're flying in, here's the localizer. More on this side, more 150, you're on the right side. More 90, more on the side, you're on the left side. You want to receive both of the same equal amount, and that's how you're right in the center. So this localizer is set to put you right on the center line of the runway. Typically when you read your localizer, it's going to kind of look like a VOR receiver, same thing, but it's going to be a lot more sensitive than a VOR. So if we look in this box here, it says course varies between 3 and 6 degrees. That means side to side, meaning from center to full scale. It's somewhere going to be between 1.5 and 3 degrees. Varies between localizer to localizer, but it's still really sensitive. You don't have that much room to play with. 1.5 to 3, yeah. And then with these localizers, they're set up to be about 700 feet side to side at the end of the runway. It's important to know that all ground-based nav aids are going to be angular-based, so that's all angular. All GPS stuff are going to be like distance-based. Cool, so that's your localizer. Your glide slope works basically the same way. You can kind of see it right here. It says 90 on top, 150 on the bottom. Right here. So, same thing. If you receive more orange, you're on top. More blue, you're on the bottom. Same amount, you're just right on glide slope, and that's what you want to be, just all the way down. However, this glide slope is separate from the localizer. This glide slope transmitter is going to be on the side of the runway. It tells you exactly where. You don't really need to know where it is on the runway. You just need to know it's off the side. And it's separate. The whole reason why it's separate is because this glide slope antenna can go out and you can just shoot the localizer without vertical guidance as a non-precision approach. With both, now you can have both vertical and lateral guidance, ILS, precision. With the glide slope, though, it's a lot more sensitive than the localizer. You thought the localizer was sensitive. The glide slope, only 0.7 here on either side, and this can be standard across all ILSs, meaning from wall, full scale to full scale, you have 1.4 degrees on either side, which kind of makes sense because it brings you down pretty low. The more they increase it, the greater chance you hit the ground, so it's kind of good that way. All right, so that's the guidance of ILS. The next one we have range. So range can include DME. We covered that one in the last video. It works the same way. Marker beacons. Marker beacons are new though. So if we go down in this AIM, you'll eventually get to marker beacons. These are all your different marker beacons and their indications. So each one has a Morse code and a light associated with them. So outer marker, all dashes, blue. Middle marker, dot dash, amber. Inner marker, all dots, white. Back course, we'll talk about this one in a sec, but it's also white, but dot, space, dot. How I remember it, it progressively gets faster the further inward you go. So each marker beacon has its own separate meaning. Outer markers will be the final approach fix for the non-precision approach of the localizer, aka this is going to be around where you do glide slope intercept on a ILS with a broken glide slope. So final approach fix essentially. Middle marker. So middle marker says 200 AGL, approximately. So this is essentially your DADH for your Cat 1 approach, which we'll cover what Cat 1, Cat 2, Cat 3 means in a sec here. But final approach fix, or not final, DADH Cat 1. Inner marker says mandatory for Cat 2 ILSs. And again, we'll cover what Cat 1, Cat 2, Cat 3 means, but essentially this one goes down to 100 AGL. All right, so how marker beacons work though. I kind of think it's like a sprinkler, right? If you set up a garden sprinkler and you run through it, you get wet, but you only get wet when you run through it. Same thing with marker beacons. It's a ground station that's constantly spraying up signals. Your plane has an antenna that's constantly receiving these and listening for these signals. The moment you cross through it, right, you get wet. That's when you get the Morse code and you get the light. Get out the other side, you stop. Hit another one, you get the light and get the Morse code. And they're constantly doing this. You're always listening, you're always there, always spraying signals. Never stop. Get wet, dry. Get wet, dry. If you're curious what the signals are megahertz wise, it should be in the same somewhere. Cool. All right, so back course. If you read up here, it specifically says it's for the final approach fix of the back course approach. So what is back course? Let's see here. Here again. So the localizer, might have noticed that it goes out two sides. So we call this the front course. You're intending on landing on runway 27, right? And so this orange side will always be left of course. This blue side will always be right of course. Same thing goes over here. If you find the miss and fly straight out, you're not reversing whatsoever. But sometimes airports are cheap and they don't want to install new ILSs. So then they just use the localizer for front course and also the same localizer for the back course, but now you're reverse sensing. There we go. So anytime you're traveling backwards on the intended course of the original localizer, you're reverse sensing. Because blue is supposed to be on the right. Orange is supposed to be on the left. In this scenario, it is opposite. So this side or this side, either way, you're going the opposite direction, you will reverse sense. So that's the back course. The back course approaches, right? You'll have one normal approach over here, and then back course approach over here. Wherever the final approach fix is on this back course approach is your back course mark beacon. All right, so that's marker beacons. Then you have visual information. All ILSs must have some type of lighting of some sort. Let's see, airport lighting. So that's where we get this. All right, you'll have one of these. But they're mandated to have some sort of lighting system. So that includes PAPIs, ALSF 1, ALSF 2, MALS, or stuff like that. There we go. Here we see the localizer service volume. There's a few other things about ILS and localizers as well. You have a thing called an LDA approach. It stands for localizer type directional aid. Essentially, what this is a it's a localizer, but not centered with the runway center line. So all ILSs will take you dead center on the center line if when you touch down. The LDAs can be offset, but not more than 30 degrees. Sometimes you have LDA with glide slope. It's basically an ILS, but it's not centered with the runway. And then finally, we have some errors. We talked about reverse sensing, right? Anytime you go to reverse of the intended course, you'll be reverse sensing. There's also reflection, right? If you park a car next to the glide slope antenna, you could reflect that glide slope frequency around. That would not be good. And then you also have false glide slopes. So instead of the glide slope just shooting out one signal, this one you're supposed to follow, it shoots out one at 9, 15, 21, stuff like that. So we always want to intercept the glide slope from the bottom, so then we always intercept the best glide slope. You might think this is obvious that you caught a false glide slope, but not true. A lot of airliners and other advanced aircraft use autopilot to intercept these things. Your autopilot's pretty stupid. It won't notice that you're traveling at over 2 times the vertical speed that you intended to. So all this means is if you intercept one of these, you will smack down into the ground really freaking hard and probably crash. So always intercept from the bottom. Verify that you're at the correct altitudes on your plate. Let's see, anything else? Oh, yeah, that's right. Cat 1, Cat 2, Cat 3. All right, so Category 1, this is what most of us can fly. This most basic ILS. What defines it is minimums. So basic Cat 1 minimums, half statute miles, aka 2,400 feet RVR, 200 feet DH. Won't get any lower than that. You can lower down to 1,800 RVR if you have a HUD, but that's not really applicable to GA. Then we go to Cat 2. The higher the category, the lower the minimums. So Cat 2 DH goes down to 100 feet above the ground. RVR goes down by half. It goes down to 1,200 RVR. So that's why we have inner markers to now alert that you're getting really close to freaking ground, 100 feet. And then we have Cat 3. Cat 3 has 3A, 3B, 3C. 3A, your DH remains 100, but your RVR goes down to 700. 3B, your DH now halves again, goes down to 50. RVR stays 700. Actually, no, it goes down to 150. 3C, I don't think this exists in the United States yet, but that's 0, 0. And realistically, if you land at 0, 0, you can't taxi the gate, so that's not going to happen. Anytime you have stuff inoperative with an ILS, if your glide slope fails, revert to localizer non-precision approach. Obviously, if the localizer fails, you don't have any more lateral guidance, can't shoot the local ILS whatsoever. And then if your approach lighting system fails, where is it? Well, if your approach lighting system fails, you add 1/4 mile of visibility onto your minimums. That would be on the first page of the TPP, actually.